Hello children. So in our previous class we have discussed so many aspects and problems on pair of linear equations. Again today I am going to discuss the same chapter of different concept. That is, today's concept is graphical method. Graphical method of pair of linear equations. Pair of linear equations. Okay. So here in our previous class we discussed just which methods are required to solve the pair of linear equation. That is, one is graphical method, another one is algebraic method. Today again I am continuing the some several steps and interpretations regarding the graphical method of pair of linear equations. So now consider, if two equations are given, consider these are the algebraic expression. Of course they are pair of equations because linear means here their highest degree may be 1. So always the highest degree of the two variable, because here it is two variable, x and y are the two variables in which their highest degree must be 1. So that is why it is known as pair of linear equations. Consider any lines which will be drawn on a graph. Then what are the possibilities? So that is, if lines representing, if lines here, take two lines, here two lines here. So that is why I written lines. If lines representing on a plane means here graph sheet, then if which has means no solution, Consider if lines representing on a plane which has no solutions, means what? It becomes no solutions, means we cannot find their exact solutions. In order to taking the two simultaneous equations, what happens when you represent on a plane? Suppose they have no solution, means what kind of lines they are, means what kind of equations they are. They are parallel. Remember it, they are parallel, and hence they have inconsistence in solution. Okay, and they are called inconsistent. Okay, they are called inconsistent. Remember. In the same way, consider if lines representing on a plane, if you draw, okay, which has a solution, means what? Which has a solution means, so they are intersecting, means the equations are in the form of straight line. Here two more equations are there, so that is why their equations here become parallel, and here when you represent on a plane it become intersecting. So that is why. So they are intersecting, means the lines, pair of linear equations are intersecting lines. Hence what we call they are consistent. Call it as consistent. Remember the word inconsistent, consistent also. Here, if you take any pair of lines, okay. So here, pair of two linear equations lines, these are all. So if lines representing on a plane, on a plane which has which has infinite many solutions. Infinite many solutions. Infinite many solutions means they are coincident, and they are called as coincident, and probably they are known as, and this coincident pair of linear equations are dependent, and they are called dependent. They are called dependent pair of linear equations. Okay, or here we can call it as, if lines are represented on a planar graph which has an infinite many solutions, means they are coincident. They are coincident or they are dependent pair of linear equations. By these three conditions, again we have to consider their examples. Before going to examples, now consider any of the pair of linear equations. What is their what are their graphical and as well as algebraic interpretation? So now I want to explain you all, that is, how would you confirm whether it is a consistent, whether it is a inconsistent, whether it is a dependent variable, means dependent pair of linear equation, otherwise it is a unique solution, and it is a solution, and it is no solution, and it is a infinite number of solutions. One is unique solution, another one is no solution, and another one is infinitely many solutions. These are considered under some sequences. That is how I will explain now by using some table. Okay. Dear children, now consider this tabular column. Why I represented over here, to understanding how the pair of linear equations in two variables which contains the graphical representation. Okay, so easily you can compare and the both geometrical and as well as algebraic method. So by using this tabular column, I would like to explain like this. So consider the ratios. Here any equations. For example, here I written these are the three examples from the textbook. So otherwise you can take any examples also, but represent them neatly. Compare. Consider ABC. Consider ABC or coefficients of pair of linear equations containing the variables x and y. Okay. AB are the coefficients of x and y. What about C? C is also any constant or real number. So that is why consider ABC are coefficients of the given pair of linear equations, in which I took, for example, if it is a first one equation, means it happen A1, it happen, so like this B1, it happen A2, and it is B2. So like this, I will take their coefficient. Now here I written the table. Look over here, the ratio, first ratio A1 by A2, B1 by B2, C1 by C2. Comparing the ratios. On comparison, you will get some idea. So which lines are represented, what kind of property are they? So and how do you interpret them algebraic method? In the same way, so I would write over here. Consider their first coefficients. Coefficient means here I already told x means it is a variable, y variable. Its coefficients are AB. If it is any other constant number is there or real number is there, consider that is C. So that is here A. A is A1 means 1 by minus 2, and here 3x, okay, 3 by here A1 1, A1 it is 1, A2 here, A2 means here it is A1 and it is A2, so that is why it will become 3. Now consider B1 minus 2 divided by 4, because it is B1 and it is B2. In the same way, here C1 is not there, so without that we can put 0, because if you write in the standard form it becomes 0, so that is why. Minus 20, here it is minus 20. So one expression over. Okay. What it says, see here, compare the ratio. Compare the ratio means consider their ratios are equal, whether A1 by A2 is equal to B1 by B2 or C1 by C2. How would you compare? Compare the ratio means these are the ratios I have written already. So compare them one by one. 1 to this ratio, this to this ratio. Now here compare, on comparison of this one, we will get some idea. That is 1 by 3 minus 2 by 4 means 1 by 3 is equal to minus 2 by 4. Is it equal? No, it is not equal. Okay, so that is not equal. Hence these two are like this, A1 by A2 and B1 by B2 are not equal here. Means these two ratios are not equal. Means the graphical representation looks like they are seems to be intersecting lines. Intersecting lines. You know that just now I completed what is the solutions for the intersecting lines. Yes, there is a unique solution. By algebraic method, if you interpret this intersecting lines, so it shows us unique solutions. It is unique solutions. So first of all, in the same way, second one, consider this A1 and it is A2. Similarly, B1, B2, C1, C2, like this. Okay. Here A1 means 2 divided by 4. It is already A2. B means 3 divided by 6. C means minus 9 divided by minus 18. Now compare the ratios like this. Okay. Here I took only 2 means. Here only 2 means. What happens is C? C is already 0. It is 0. There is no other. There is no other comparison of the ratio. Here, so that is why I left out this one. Okay, A1 by A2, B1 by A2, only comparable. Not C1 by C2. C1 by C2 is always equal to 0. If you become 0, it will always become 0. So that is why consider these two. Now consider this one. A1 by A2, A1 by A2 is equal to B1 by B2 is equal to C1 by C2. How to appear? 2 by 4. 2 by 4. It is equal to 3 by 6. Is equal to minus 9 by minus 18. So here 2 ones are, 2 twos are, 3 ones are, 3 twos are, 9 ones are, 9 twos are, because minus cancel. Means all these ratios are same. Yes, these are same. It means the ratios of A1 by A2, B1 by B2 and it is equal to C1 by C2. All the ratios are must be equal to one another. Here should be correct. So that is why graphical representation says us this is a coincident. Okay, coincident lines. These are appears in a graph like coincident lines. Of course, the algebraic interpretation is like this. Means it is infinite many solution, infinitely many solution. So that is the solution. It is a infinite many solution. Now take the third one. What happens here? A1 is here, A2 is here, B1 is here, B2 is here, C1 here, C2 here. Now take 1 by, so 1 by 2 and here 2 by 4, and last one minus 4 by minus 12. Compare their ratios. A1 by A2 is equal to B1 by B2 and here C1 by C2. So what happens here? It is 1 by 2. It is equal to 4 by 2 by 4. It is 2 by 4. Is 2 by 4 and which is also equal to minus 4 by 12. Compare now. Yes, 1 by 2. It is a reducible form. Now 2 ones are, 2 twos are. 1 by 2 it become. So 1 by 2, 1 by 2 equal. But here what happened? 4 ones are, 4 threes are. It become minus 1 by 3 it is. These two are equal, but this is not equal. Hence, this interpretation shows us like this. So what happens? It seems to be a parallel line. So that is why it is known as parallel. On graph, these are represented look like a parallel lines. So that is why. So based upon these ratios, comparison of the ratios, you just conclude graphical representation and as well as algebraic representation. So graphical interpretation over. Now algebraic interpretation. What happens is algebraic interpretations? Look here, no solution. Here no solution because the lines, very simple. If lines are intersecting, at least they are meet at a one point. Means they are intersecting at a one point. If lines are intersecting at two distinct points, means infinitely there are many solutions because not only two, there are the two lines may be coincident. Means they have touching one another, means they are intersecting at one another at so many points. That is why the lines are coincident. So that is why it is known as infinitely many solutions. And take the parallel. Parallel means they never intersect. They never intersect. So that this shows us, this tabular column says us how the lines, if you draw the graphical representation for the pair of linear equations. Suppose you draw the pair of linear equations in graph. So this shows us only three conditions, that is intersecting lines, coincident lines, parallel. What is their interpretation? If intersecting lines is there is a solutions, means they are consistent. If coincident lines means they are definitely, they have infinitely so many solutions, means they are dependent pair of linear equations, and one to another one dependent. That is why parallel means there is no solutions at all, because they are never intersect, so that is why they are inconsistent. Similarly, you can call it as consistent. It is known as consistent, and it is known as dependent, and it is known as inconsistent. So according to this interpretation, so many examples are solved. So go through your textbook also. Now take one example. Okay. Now take the second. So second kind of examples I written over here. So consider any linear equations like pair of linear equations. These two are pair, these two are pair, these two are pair. So that is why. So consider their ratios now. Consider A1, A2, B1, B2, C1, C2. So what happened here? 5 divided by 7. It is next one 4. It is 4 divided by 6, because B1 minus 4 it is, because here B1 minus 4. And similarly C1, it is plus 8. It is plus 8 and divided by minus 9. Consider the first. So compare now. What happened? A1 divided by A2 is equal to B1 divided by B2 is equal to, here C value is also there, C1, C2 value. So here C1 is divided by C2. What happened here? 5 by 7 is primary. So it is all prime numbers, no reducible. So here minus 4 by 6. Minus 4 by 6 can be again 2 by 2, 2s are 2, 3s are. Yes. 8 by 9. 8 by 9 minus 9. So there is no common factor. So values are look like this. Minus 2 by 3, and which is 8 divided by minus 9. So look here, 5 by 7 is not equal to this one. So all are not equal here. It means there may be a coincident. Means coincident lines. These are called coincident lines. Okay. These are coincident lines. What happens? It's algebraic interpretation. Dependent pair of linear equations, and they have infinite many solutions. Infinite many solutions. In the same way, so take down the second comparison, the ratio. So what happened here? 9 divided by 18, 3 by 6 means all are positive. 12 divided by 24. 12 divided by 24. Okay, now look here, 9 by 18, 3 by 6. Okay, all are comparable. Yes, A1 divided by A2 is equal to B1 divided by B2 is equal to C1 divided by C2. Whether these are all equal? Yes, of course they are equal, because they are 9 ones are 9 twos are, 3 ones are 3 twos are. So 12 ones are 12 twos are. Means all are equal here. It means what is the graphical representation and algebraic interpretation? Means, sorry, here line coincident. Here line is coincident. Here intersecting. Here is intersecting. Here is intersecting. So you have a definite solution. Means a solution. Have a solution. Unique solution. It is unique solution. So it is coincident. Coincident means infinite many solutions. Infinite many solutions. So next one, third one. Okay. So now take given 6 divided by 2 minus 3 divided by 1. Okay. 10 divided by 9. Here. Now take, so 6 by 2, consider A1 by A2 is there. B1 is equal to B1 divided by B2 is there. And it is equal to C1 divided by C2 is there. So that is why here it is equal to B1 divided by B2. Now compare the ratios. So now compare first one, 6 by 2. It is equal to Here it is minus 1 divided by minus 1 here. So minus 1 divided by minus 1. So that is why minus 3 divided by minus 1, it is equal to 10 by 9. Look here. So 2 1s are 2 3s are minus minus cancel, 1 3s are 3. Means 3 is equal to 3, but it is not equal to this one. So it shows us these two are equal and this is not equal. If first two are equal, last one is not equal, means they are parallel. There seems to be a parallel lines. In a parallel lines, what is the interpretation? So no solution. Now these pair of linear equations have no solutions. It is okay. So here first one is intersecting lines, means intersecting lines. These are coincident lines. Lines are coincident. Their lines are parallel lines. Their interpretation unique solution. Have a solution, definitely solution. No infinite solutions. Here infinitely many solutions because lines are merged. So here no solution because they are parallel. By this tabular column, we can easily understand how the graphical representation appears. If two lines are intersecting, whether parallel, whether coincident. So this can be easily understood by using this tabular column. So remember the ratios. Here this ratio comes means those are intersecting. This ratio comes means this is lines are coincident. This ratio comes means this is parallel lines. By using this, we can solve the exercise problems also. In the next class, I would like to explain so many problems based upon the graphical representation of the pair of linear equations. Thank you.